Hello class, welcome to our lesson today dealing with section 7.2. This section is a little bit more challenging than the first section. Not that the first section wasn't challenging, but the first section always had two angles given to you at all times. And so the law of sines works perfectly with those situations as long as you have two angles and one side length given. Today we're looking at two side lengths and an angle given to you, which if you remember in geometry was always a problem when you tried to solve things when you're given two side lengths and an angle and that angle is not between them. So when we deal with questions today, that's why it's called the ambiguous case of the law of sines, because there's going to be some issues that we need to discuss as we're solving. Okay, the setup is all the same. So you still draw a triangle out. A, B, and C are the angles opposite of A. So notice this is 50 because it's opposite of angle A. B is opposite of angle B. But notice here, I have a ratio set up already. Okay, so this scenario will typically have this setup where you have a ratio given, but you are missing this second angle. And once you get the second angle, then you can roll with the third, etc. So you set up the law of sines. Sine of B over 26 equals sine of 95 over 50. Cross multiply and solve. Now notice here when you get down to this, 50 sine B equals 26 sine 95, then divide by 50. And then you have sine B equals 0.518, and there's more to that number. I would suggest keeping that number entirely on your calculator as you're solving. Remember, to find an angle, though, you have to do the inverse feature of your calculator, so sine inverse of 0.518. The problem is when you do sine inverse always will give you this first answer in quadrant 1 of 31.2 degrees, excuse me. But because sine exists in quadrants 1 and 2, it's possible that the other answer could be 180 minus that. So you want to make sure that you're used to writing those down. So it's 31.2 or it's this other number. And then once we get that piece set up, what we look at is say, okay, let's say B does equal 31.2. Can I find C? If I take 180 minus 95 minus 31.2, that's where this 53 number comes from. But B also could have been legally in quadrant 2. The problem is if it works for a triangle, then the three angles should add up to 180. And if this angle is 148.8 plus 95, the third angle would be negative, so it doesn't work. You probably want to go that route rather than the other route, which is, I'm not going to worry about the second group until I have to, because you won't know when that will occur. So you want to make sure that you're dealing with both ideas. So there should be two versions of the law of sines when you do the inverse. And most likely, okay, one of three things will happen. Either they both work, only one of them works, or none of them work. Okay, so those are some things that you want to think about as you're looking at that scenario. So continuing this question, the first one, 31.2 degrees works with 53.8. And then you can use the law of sines again to find the missing side length. So sine of 53.8 and then over C equals sine of 95 over 50. Notice I'm using the same A information from the first slide again. And then cross multiply. Now this should look like what we did in the previous lesson. And then you find side length C. And that would solve the triangle for this first scenario. Okay, the next example will have a situation where both versions will work. So notice here the example is set up with angle B and side length B are across from one another and they go together. I obviously have to solve for angle C first because I have side length C given to me. So sine of 54, the angle, divided by 23 equals sine of C, unknown, over 28. Cross multiply, divide out. Okay, you get this 0.98 number for C, sine of C, excuse me, and then you have to do sine inverse, okay, in order to find that answer. Again, I hope that all my numbers are right. Sometimes when you're plugging stuff into a calculator, you're off a little bit. So hopefully that they're close or at least on track here. If something's up, I'll make sure to let you know. Sine of C, when you do inverse, should be 80.03. But since sine is positive in quadrants 1 and 2, it also could be in quadrant 2 as 99.97. In this case, if I say C equals 80.03, so that's why it's C1. If I take 90 minus 54 minus the 80.03, then actually this works as 49.47 for angle A. If I instead use the 99.97 and subtract out 54 and 99.97, excuse me, from 180, it also becomes 23.03, which works. Which means there's two versions of this triangle, and essentially here's what's happening. One of them is going to be like this, and one of them is like this. So it's like a swinging gate. So one could be an acute angle and the other could be obtuse, and it still makes the triangle based on the information that it gave you. Because all that you set was this and this angle, and so you can move that around and it will still work. And that's why this triangle has two versions that could be an option. So going back to the first version, now that I know angle A and C from the first version, I just use that and do my law of sines. So sine of 45.97 over A, and then sine 54 over 23 are used again. Cross multiply and solve for side length A, 20.44. So that's one set of answers. Okay, that's one triangle that's possible for that situation that would be an acute triangle. And now I use the other two angles. So use C2, which is 99.97, and A2, which is 26.03. Plug that into the same formula with the law of sines. Instead, I use sine of 26.03 with side length A and angle A, as opposed to what I had before. I cross multiply and I solve and I get 12.48. So there's two distinct sets of answers. One triangle would be this first one on this slide, and then another distinct set of answers with the second slide. But it all stems back to when you first do the inverse trig function. So when you do this inverse sine right here, write down the answer that you get and then take 180 minus it, because sine could have existed in quadrant 1 or 2. And essentially that number is the reference angle. And you'll find both versions and then see if they work in order to be successful on that scenario. If you're looking at homework and test questions, it'll say like there's one solution, here it is, there's two, and here they are, there's none, and here and there's nothing. So you want to pay attention to what you're looking at. A lot of times you'll be able to tell fairly quickly just because of the angle when you take 180 minus it to find the secondary version or the second version of the triangle. Okay, the third question here gives you side length C and angle C. So side length C is 60, angle C is 100. So the first thing you got to do is find angle A. So sine of A over 82 equals sine 100 over 60. You do your cross multiply, divide by 60. You get sine A equals 1.346 and do sine inverse. And this is the best scenario for what many students see, which is it doesn't work. Most people when they first start say, well, that can't be, and so they do it again and it still doesn't work. And so there's no way to make a triangle with that given information. So there's no solution. That question doesn't take very long then. So really they balance out. So the fact that this one doesn't take very long and the last one took kind of twice as long, they kind of balance themselves out for how long they would take overall. The reason that this one doesn't work is because you're saying that this is 100 degrees and this is 60 across from it. If this is 82 for a side length, this angle has to be larger than angle C because this side length is larger than 60. But there's no way that you could get an angle larger than 100 and make a triangle because you'd already be over the 180 degrees. All right, so what you want to focus on today is there one set of answers, two sets of answers, or no sets of answers. Anytime you do the inverse sine, you should have two answers that you look at, see if they both work, and then you find the side lengths and missing angles based upon that information. Have a good day, everyone.